guys. Sorry, I just got home, so I was getting settled real quick.
Oh, you're good. Do you want me to share my screen, or do you guys want to pull up on your own? For activity A, it looks like it's just filling out a form, unless you guys need to review the videos again. Do you guys want to watch the videos, or feel comfortable with the maximums?
I'm probably okay without the videos, because this is the same stuff we've been doing on the test too.
Yeah. So if Mary's okay, we'll just do the worksheet.
I think I'm good.
Expiration.
Oh.
Activity B.
Do you guys see my screen with the worksheet? Okay.
There we go.
I can't see what that. If it's not the right thing, let me know. Okay, so I guess we're just creating graphs with the different characteristics. So the first one, we need a graph that just has one global max. Or that just be an upside down parabola?
Yeah.
Yep.
Or are you supposed to do like this graphs, I guess?
I would think so.
Okay.
I think it's basically
No, like function.
out. Yeah, I don't think you need a function.
All right. So we need a global min, a local max, and a local min. I feel like this is kind of hard to do as a group.
Yeah. I think it was kind of like last week.
Yeah.
Where it's like,
Like, how do you show it, and then
would it maybe be easier if, well, I guess it would involve looking ahead though, but maybe next time we could look ahead and see what the activity looks like. And if it's something like this, maybe we can just have filled out the worksheet and kind of put that on screen, and we can just kind of compare. I don't know.
How about for today, since you want to just like maybe review the answer key and see if it makes sense?
Yeah, that's great.
Or do you want to do it first before you look at it?
Given
whatever you guys want to do, I am fine with whatever.
Okay. I'm okay with just reviewing that part, but I get it if like you guys want to look at it first so that you kind of see if you know what you're doing.
I'm cool with just looking at the key for now.
Okay. And then maybe next week we can maybe look ahead and see, and come, like you said, Mary.
Mm-hmm.
Okay. So that first one we were right. We had an upside down parabola. I feel like it makes sense. Global min, global max, local min.
I feel like this is something that got discussed at least a little.
Yeah.
But not maybe with the same. I mean, obviously not with the derivatives. Not in this vocabulary, but I think we went over. Like,
yeah, it's pretty basic. Like,
yeah.
I feel like there's not any. And under what conditions do maximum and minimums happen? We know when the sign changes from positive to negative or negative to positive. And then suppose a function is for x values in the closed interval -1 to 1. Is it possible for it to have no maximum or minimums? Which makes sense. We did the extreme value theorem for our prep yesterday. And is it possible for a function to have 2 or more maximums without any minimums? No, because you have 2, you'd have to go down and up. Are you guys cool with that, or
I think it makes sense.
Okay, so there's an activity B, so let's see maybe what this activity B is about. So this does have a video. Do you want to watch this one?
Yeah, sure. Let's just pad our runtime.
Yeah. So we have enough to submit. Is that bad? That's kind of horrible, right? Whatever, we're going with it.
Critical points, finding critical points to help us determine what are our maximums and minimums and our intervals that are increasing and decreasing. So in order to find any extrema, we first need to find critical points, and we do that by taking the derivative. We'll have 3x squared over 3 minus 4x, and setting that derivative equal to 0 or undefined. Yeah, well, if we examine this function, that is a quadratic function. It's never undefined. So, but we might get some critical values from the derivative being equal to 0. So if I have x squared minus 4, I can factor out an x, and we'll have x times x minus 4 equal to 0. Two things are multiplied together and they equal 0. One of them has to be 0. So either x is 0 or x minus 4 is 0 and x is equal to 4. So these are both critical values, or critical points actually, because they exist in the function. And we want to make a first derivative chart, which is a number line. I'm going to put derivatives on the top of the line, and I'm going to put x values on the bottom of the line. So my two critical values are 0 and 4, and I know that the slope is 0 at x equal to 0 and x equal to 4. So to do the first derivative test, I'm going to pick some point that's less than 0. How about -1? And I'm going to plug it into the derivative. It's easiest to plug into the factored form of the derivative if you have it. So if I plug -1 into the first factor, I will get a negative. And if I plug -1 into the second factor, I'll get a negative. I don't even care what the numbers are. I just need to know if it's positive or negative. Well, a negative times a negative gives me a positive. And so the slope is positive when x is less than 0. Let's look at, say, +1. Number between 0 and 4, an x value. If I plug x equal to 1 into this factor, I get a +1. If I plug 1 in here, I get a -3. As I said, I don't really care what the number is. I just care whether it's positive or negative. So this product will be negative, or the slope is negative. Let's look at, say, 5. If I plug 5 into the first factor, I get a positive, and if I plug it into the second factor, I get a positive. So my product is positive. The slope is positive. Now I could just plug it in right here, plug these values in to see whether I would get a positive or a negative slope, and that would have worked just as well. So what do I see? Well, I see that the slope changes from positive to negative. It's going up, it gets flat, and it's coming down, it's coming down. That means I must have a max at x equal to 0. likewise, I have the slope changing from negative to positive, and so it's coming down, it flattens out, and it starts going back up, means that 4 must be a minimum. And to find my intervals of increasing and decreasing on my function, if the slope is positive, the function is increasing. So I'm going to represent increasing with an upward pointing arrow. This graph is increasing from negative infinity to 0, and again to infinity. I didn't include 0 and 4 because the derivative isn't positive at 0 or 4. The derivative is 0, and the function is increasing if the slope is positive. Likewise, I'll use a down pointing arrow to represent decreasing. My function is decreasing when the slope is negative between 0 and 4. Okay?
Easy enough.
Yeah, seems pretty good. And then there's a practice worksheet. There's 4. Do we want to do these or
Each tackle one, and then do one as a
do we
group.
want to do one?
Makes sense to me.
So technically, we don't have a time limit that we're supposed to be doing, right?
No.
So I think maybe since I feel like we're all pretty confident in this, do you feel comfortable saying this was good enough for this week, or?
Your call, Soren.
My call? Okay. That way we can have Professor Carlisle come back to me if she doesn't like our video.
Well, I feel like we all kind of have an understanding if like we need help, we can always reach out to each other on the Google Hangout chat.
Yeah. I feel really confident in reaching out to you guys if there is anything that I am confused about.
Definitely a valid point. Well,
Okay.
I feel like this is the easiest concept. I mean, honestly, for me, this is the easiest concept we've had since the power rule for me.
Yeah. Like, I don't feel like it's very difficult.
no, it's not.
I'm sure it'll get difficult soon.
Yeah, I'm
But for
sure
me, it's nice.
into it. That seems about right.
I feel like where it's going to get difficult is where, you know, you have this on top of a complex derivative, you know, so you have to find, you know, when you find that first derivative, then you're having, you know, the difficulty of the derivative more than.
I struggle more with, like, on the test, like, the stupid problems. That's where I get all my points taken away. I don't know how to do those for some.
Ooh, that's a good point. I hope there's not any, like, word problems for these.
Yeah, I don't know. I feel like, I don't know.
Maybe they can be better. I don't know, but the ones where it's a word problem that's like relates to trig or related rates.
Yeah.
Like those ones, like I can see it. I can do it when I can see previous examples.
Yeah, that's how I am, but I can't, like.
The testing center, it's like you can't use your notes, and it's like this is what I remember of how to do it, but I'm not sure that it's right. But
yeah, I kind of struggle with that part.
At any rate,
and I feel like we don't do any in between, so then it's like hard for me.
Mm-hmm.
Like, because you don't do it like all these other ones, like you are getting practiced in derivatives and integrals, and then on the test it's like, here's some story.
Mm-hmm.
All right, well, I'll end the call, and then I'll go to our Google Hangout, and if you guys have any issues, just reach out that way, okay?
We appreciate
All right.
it. Thank you.
Okay, thanks, guys.
Bye.
Bye.